just allow a few moments for people to come in.
You're going to do a brief introduction first, Jay.
Yeah, just waiting a moment. We can see the participants coming in. We're up to 25 now. Just allow a few moments for people to join us.
I just want to say thanks again to Matthias, Inesy and Pierrick for agreeing to come on and speak. Thank you very much.
Oh, thanks to you for the opportunity. Yeah, thank you.
I'm looking forward to hearing your presentation.
Okay, welcome everybody to SELKIE's third supply chain webinar in the series highlighting the supply chain opportunities for the wave and tidal stream energy sector. Please sign up to the SELKIE newsletter for all information on future events, including our skills webinar on the 19th of January. A link will be provided in the follow-up email to today's webinar, and today's webinar will also be recorded for future viewing. So firstly, allow me to introduce myself as chair. My name is Jay Sheppard. I'm the Marine Energy Project Manager as part of the Marine Energy Wales or MEW team that is supporting and delivering the SELKIE project. So MEW is the industry-led stakeholder group representing the wave, tidal and floating offshore wind industries in Wales. MEW brings together over 50 member organisations, including technology developers, test centres, wider sectoral alliances such as the Celtic Sea Alliance, the supply chain, academia and the public sector to establish Wales as a global leader in sustainable marine energy generation. Our vision is to create a thriving and diverse marine energy industry in Wales, creating economic opportunity while working towards net zero. So we're delighted to be part of the SELKIE project with the communication and dissemination aspects of the project and supporting Mentor on the business engagement and knowledge transfer from universities in the sector. Other partners involved in the project, some you'll be hearing from today, include University College Cork, Swansea University, DP Energy and Gavin Doherty Geosolutions. So following on from our second webinar that focused on operations and maintenance opportunities in the marine energy sector and its potential in utilising existing maritime expertise, in this webinar, we'll be delving deeper into foundations and moorings opportunities, the F&M tool that's being developed by SELKIE and the experiences of a site developer and offshore engineers. So much of the design methods used for marine renewable energy sector are based on the experiences of the oil and gas industry. There are obvious differences between the oil and gas structures and wave and tidal structures, so employing the same methods does not lead to optimal design. For wave and tidal energy, what is required is a methodology that will produce a safe design at the lowest cost, and our speakers will be delving into that a little bit further today with reference to foundations and moorings. So before I introduce our first speaker, I'm just going to go over some housekeeping and general guidance for today's event. So all of the attendees are on mute with no video to ensure that we can hear all the panelists clearly. If you need any assistance at any point, please click the raise hand button or send a message in via the chat. You'll be able to see our panelists who are welcome here today, and they will be sharing their screens, showing you a presentation of their projects. We'll be holding a Q&A round at the end of the session, so feel free to send in these questions as they come to you. You don't need to wait until the end, and you can submit these via the Q&A icon at the bottom bar. So please use the chat for technical assistance and the Q&A for any questions you have for our speakers. And then again, this webinar will be recorded and we'll be sharing that following the event. So without further ado, I'll introduce you to our first speaker, somebody who I've been working with in preparation for all of these SELKIE events. So we have TJ Horgan from UCC. He is the SELKIE Project Manager.
Thanks, Jay. I am TJ Horgan. I'm based in UCC MaREI, which is the Marine Renewable Energy Ireland, based in Cork Harbour. And I am just going to give a brief introduction to the SELKIE project and what we want to achieve. I would encourage everyone to get in touch with us on our website, Twitter, or LinkedIn. Join our network and speak with us, and we can see if we can help each other in some way. I would also ask everyone, we have a very short Minty survey, and if you could please go to minty.com and use this code 8174634 for the webinar. We'd appreciate that. Okay, a little bit of what we're about. We are a Wales-Ireland collaboration, 6 partners. We have €5 million funding over 3.5 years. We're 1 year in, and 80% of this is EU contribution. The coordinator is UCC MaREI. Our speciality is wave energy technology and techno-economics. Lead partner, Swansea University. Title Technology and Sensors. GDG, Gavin Doherty Geosolutions, based in Dublin, Ireland. Foundation and Moorings. DP Energy Ireland, also based in Cork. Project Management and Industry Expertise. PCF, which is Pembrokeshire Coastal Forum. They are in charge of our dissemination and communication work package. And Mentor Mon, who are dealing with our public engagement and SME support. One of the tools that SELKIE will be developing is the Geographic Information System and Techno-Economic Model. This tool will have increased resolution and the most up-to-date geospatial data representing all potential opportunities, constraints, and restrictions. It will provide device-specific techno-economic recommendations for wave and tidal designs. The result will be the development of the first true GIS-TE tool in renewable energy. It will be geared specifically towards marine renewable energy applications and bespoke to Irish and UK waters. SELKIE will produce with software developer OceanTech an up-to-date operations and maintenance model for our region. SELKIE will build and validate an easily deployable and portable converging beam ADCP system. SELKIE will trial drones to measure surface currents. SELKIE will further develop and launch a low-cost data logger. The project will physical and numerical modeling of wave and tidal devices and arrays. This information will help advance the sector as a whole. And of course, today's webinar on the foundation and mooring design model. And as Jay said, it's to help designers or help developers design the most cost-effective and efficient method for the type and conditions. Our partners, Marine Energy Wales and Mentor Mon, for this project, we will be doing the knowledge transfer, business engagement and support, and providing training on our open source SELKIE tools. If any of these tools interest you, or if you wish to be part of our network, or if you just want to chat about any opportunities or questions that you might have, please feel free and do get in touch. And one last word of encouragement for the Menti survey. Please go to menti.com and use this code and complete the survey for us, please. Thank you very much, Gaurav Margaret.
Thank you for the overview there, TJ, of all the different tools that SELKIE is working on. Quite a diverse range there, and each webinar will be focusing in on a single one of these tools. Can you just remind people what's the best way to get in touch if they want to become a member of the SELKIE network there, TJ?
The best way and the easiest way would be go to the website and sign up.
Yeah, so that's selkieproject.eu, I believe.
Mm-hmm.
Yeah.
Or on Twitter, direct message.
Cool. Great. So from that basic overview of the tools there, we're going to delve into one of the tool that will be the focus of today's webinar. So we have Dr. Paul Bonar from Gavin Doherty Geosolutions. He's going to be giving us an overview of the foundations and mooring system design tool that's being developed as part of SELKIE.
Thanks, Jay. Can you hear me okay?
Yeah, I can hear you.
And you can see my slides in full screen, hopefully.
Yeah.
Excellent. Okay, thank you for that. Okay, well, I'll make a start then in that case. Good afternoon, everyone, and thanks for coming along to our webinar. As Jay said, my name is Paul Bonar. I'm a research engineer at Gavin Doherty Geosolutions, and we're leading the foundations and mooring systems work for the SELKIE project. So we're working with our partners at UCC on this. And today I'd like to introduce the decision support tool that we're developing and invite any thoughts or suggestions that you might have. So my talk will be followed by shorter ones from my SELKIE colleagues, Majid, who's going to discuss some of the existing tools in greater detail, and then Kate, who's going to introduce her master's project as well. Oh, try and get to the next slide. There we go. So I'll start today by putting our work in context, really. The key thing is noting the key challenges in the design of foundations and moorings for marine energy projects. And then I'll discuss some opportunities for improvement and cost reduction as well. I'll then introduce some of the existing decision support tools, as well as our ideas for the SELKIE tool. And I'm going to keep this talk at a fairly high level, just for the sake of time, but do feel free to ask questions or get in touch if you'd like to discuss any of these ideas further. We want to design this tool to provide as much value as we can to the end users. So we've also produced a survey to ensure that our work is aligned with the needs of industry stakeholders. And we can share a link to this in the chat, and I'll discuss it more at the end. So making a start, as we know, marine energy devices can be either fixed to the seabed with a rigid foundation or floating and secured with mooring lines and anchors. In the offshore wind and oil and gas industries, fixed structures can have a lot of different foundation types. I've listed some here on the left, and floating structures generally can have catenary, taut, or maybe semi-taut moorings connected to different anchor types. Again, I've got a list there, but there are plenty you can see. The choice of station keeping system depends on the characteristics of the structure and the deployment location. But the idea is that each system will be designed to secure the structure or device in a way that's reliable and cost effective. Now, that being said, most marine energy devices have been secured with heavy gravity bases because at demonstration stage, designers typically favor simplicity and reliability over cost efficiency. And now let's have a look at some of the key challenges in designing foundations and moorings for marine energy devices. I'm sure you can all think of some, but the first one that comes to my mind is the marine environment, which is extremely challenging for both engineering design and marine operations. For marine energy, we're often targeting some of the most extreme environments, and we're doing so with new types of technology and limited operational experience, all of which can introduce risk and increase cost. And with these sorts of challenges, it makes sense to try and learn as much as we can from the offshore oil and gas sectors, which have decades worth of experience in securing structures to the seabed. So as Jay mentioned earlier, oil and gas standards have proven a useful starting point for marine energy, but their priorities are quite different. And I know my colleague Kate will touch on this in her talk as well, but I just wanted to introduce some of these key differences. So in oil and gas, the structures are usually much larger, they have crew working on them, and they generate so much revenue that the cost of a station keeping system is proportionally very small. And for marine energy devices, on the other hand, they're usually much smaller, they're unmanned generally, and instead of having a single high value asset, you might have arrays of devices, each with their own substructure, and so the foundation and mooring costs could be proportionally much higher. Marine energy devices might also have longer design lives. They can be subject to more complex loading. And rather than keep the device still, the moorings might be required to allow it to move in certain ways and by certain amounts as it generates power. Some of the other challenges include the fact that there is no consensus as to the best type of marine energy device. At one time, there may have been an expectation that one particular type would be by far the most successful, but the view now is that there could be a number of different devices to choose from depending on the situation. Wave devices come in many different forms, as we know. There are buoys and hinges, oscillating water columns, but even in tidal stream, which is the more advanced sector, there are different device types, as well as the usual horizontal axis turbines. There are vertical axis turbines as well, and tidal kites too. And then to further complicate things, the design priorities for these kind of systems will change as projects move from pilot tests of single devices, which might involve makeshift solutions and maybe large safety factors, to arrays of devices, which will require much more streamlined, efficient designs to remain cost effective. And so station keeping design then is really about finding a solution that can meet a great number of design requirements, some of which may conflict with each other, and doing so obviously within the confines of a budget and a reasonable time frame. And because marine energy devices are new technology, there's still a lot for us to learn. But if you just think about the basic requirements of a marine energy device, which are to survive in the marine environment, to generate power efficiently and consistently, to not introduce an additional threat to marine life, and ideally to produce a return on investment, you can begin to appreciate the importance of the foundation and mooring system, because that feeds into all of these considerations. And so with all these challenges, you might wonder how the marine energy industries are planning to proceed. And what experts recommend is a learning by doing approach, where good practices are adopted from other sectors, bespoke methods and tools are developed, and experiences are documented and shared. And it's on these bespoke methods and tools that the SELKIE project comes in. So as Jay and TJ said, our project is developing open source methods and tools in key technology areas to support the marine energy industries, and also providing networking opportunities for SMEs and supply chain companies as well. And for station keeping systems, the key challenge at the moment is cost. Foundations and moorings are often quoted as representing between 10 and 30% of the installed cost for marine energy, but any additional cost or saving also has knock-on effects for installation, O&M, and so on. And so as you can imagine, there's been a lot of research activity in this area. On the right of the screen there, I've just listed some of the recent projects focused on improving the design of foundations and moorings for marine and floating wind projects. And some of the key innovations, areas that they're targeting, I've shown on the bottom left. So they're looking at new technologies like lighter and more efficient foundations and anchors, which I'm sure we'll hear more about today. They're also looking at new components to reduce peak mooring line loads and new materials to make systems lighter and stronger. And for SELKIE, by far the most similar projects to our own are DTOcean and DTOcean Plus. So these projects have really set the standard for open source decision support tools for marine energy. And we're in a good position to be able to learn from them because their second project is beginning to wind down just as ours is starting to spin up. So my colleague Majid will give some more detail on the DTOcean tool in just a few minutes, but I wanted to briefly introduce how it works. So foundations, anchors, and mooring systems are usually designed using an iterative approach. Different analysis techniques are used to investigate in different levels of detail, specific failure modes for a given design and location, and the system dimensions are adjusted as necessary. So the final design usually involves commercial software and some advanced numerical analyses, but in the early stages, standard equations and other simple methods can be used to provide an initial size, cost estimates for different system types, which allows designers to quickly compare options and identify key areas for further analysis. And this is basically what the DTOcean tool does. To design a foundation, anchor, or mooring system, information about the device and site are obtained either directly from the user, from another DTOcean design module, or from a database of default values. The tool then consults a lookup table to determine the most appropriate foundation or anchor type based on their ranking, estimates the dimensions, and uses static or quasi-static methods to perform some simple design checks. So all the most common foundation and anchor types are available, and the tool will adjust the dimensions if the system is over or under designed. And if the user specifies a floating device, the tool then runs through a similar procedure to design a catenary or taut mooring system as well. So this is the overview of the first DTOcean tool, which was released in 2016, and the DTOcean Plus project is going to release a new version next year. Now, from our conversations with these projects and our review of their tools, we think that a web-based decision support tool, inspired by their work, but perhaps aimed at an earlier stage of development, would be a good starting point for the SELKIE project. So we know that the DTOcean Plus tool will include some more advanced analysis techniques, some additional mooring components, and it will also make sure that the outputs are compatible with other tools like MAP++, the open source mooring analysis program. But here I've listed just some of the key features that we've identified for the SELKIE tool. So first and most important, we've got usability. Making the tool simple and intuitive to use is obviously key, and we think that a link to the web-based GIS tool that our partners at UCC are developing, the one that TJ mentioned earlier, that could be really helpful for us. Flexibility is important too. We'd like to ensure that our tool can be used for different technologies at different levels of complexity and allow the users some flexibility in the design to play around with safety factors and that kind of thing. Transparency is also key. If we're going to suggest that one particular system type is best, we'd like to be able to show our work and give our users the final say on that. Compatibility as well. Like DTOcean, we want to ensure that the outputs from our tool can be taken and plugged into other design tools. And then finally, we've got enhancement. So where possible, we're going to try and include the latest technologies and methods to give the user the benefit of some more recent advances in station keeping system design. So that's what we think would be useful based on our reading and our conversations with other projects. But of course, we'd like to get your thoughts as well. We've produced a survey to ensure that our work is aligned with stakeholder needs. I've got the link here and we can share that in the chat box as well. And we've also included some of the key questions in the Menti survey that TJ has shared. So we want to know which industries and sectors you're working in, which design software you use, if your methods already include open source tools, and if so, which ones. If you use the DTOcean tools specifically, and also what you think will be the next big innovations in foundation and mooring design. So we've designed this survey to be quick. It should only take 10 minutes to complete. All the questions can be skipped and the responses are anonymous by default. So please have a look and get in touch if you'd like to discuss this further. We're going to use this information to shape the final form of our tool and develop generic case studies relevant to marine energy in Ireland and Wales. We're also going to have a project report coming out early next year to describe our plans in more detail. So please keep an eye out for that as well. So that's about it from me, but I'm obviously happy to answer any questions you might have either now or at the end of the webinar. So thanks very much. I'll stop sharing my screen now and hand back to you, Jay.
Thank you for your presentation, Paul. That was a really good overview of some of the considerations that need to be kept in mind while designing foundations and moorings. So the questionnaire that you talked about, we're going to share in the post-event email. So everybody will have a link. It's also been shared in the chat. So if you are actively involved in foundations and moorings, we'd really appreciate you filling that in, because that will feed into the design of this tool and make it, as a higher value open source product for all of the end users. So now we're going to go to Dr. Majid Hussain, who is working on the actual development of the tool. And yeah, he's going to talk us through that. Are you there, Majid? I think you're on mute, Majid. I can't hear you.
Yeah, hello, Jay.
Hi there.
Hi. So, can you see my screen?
I can. Yeah, we're all good.
Yeah, thank you. Can
Take
you
it
hear me
away.
clearly?
Yeah, I can hear you all good, my friend. Ready when you are.
Okay. Yeah. Yeah, hi everyone. So I'm Majid Hussain. So I will be discussing a bit about design and analysis tools for foundation and mooring systems. So we can see some of the common open source and commercial tools that are available in the offshore industry are DTOcean, as Paul was discussing a little bit about it. So it was released in 2016. So based on then DTOcean Plus has been developed and it will be released early next year. So then we have SESAM, it's a commercial software. And then we have some other tools, so like MaREI is there, Map++ is there, and Optimood is there, and many others are there. And these tools are based on different formulations. And this has been successfully incorporated into many tools like Vaxim is there, Abacus is there, successfully. Now, if we look at the DTOcean, so as Paul said that it was funded by the European Union 7th Framework Program. So what it does is it generally, the software part of the project, it generates a optimized spatial grid which models the marine energy device arrays. So there are basically 5 key computational areas. One is hydrodynamics, then we have electrical system architecture, then we have moorings and foundations, which we'll be discussing in this part, then array installation and O&M. Now, if we look at the DTOcean, so after a set of inputs, which is based on the technology type, deployment location, and also on the user-defined inputs, the output is or the assessment that comes out is basically in the terms of economics, reliability, and environmental impact assessment. So if we look at the work package 4 of the DTOcean that was concerned with the moorings and foundation design, so the set of inputs that goes into the program or the software is user-defined inputs, and also inputs from the other devices. So from these packages, the output serves as an input to the work package 4. So there is array layout, umbilical modules, and also some inputs are there from the global tool database as well. Now, all these inputs are routed to work package 4 for work package 7. Now, if we see here, there are too many inputs which are site-specific, technology-specific, as well as user-defined inputs. Now, the processes that go within the work package 4 include after the processing of all this, the multiple solutions are generated. Then from that, the solution with the lowest capital cost that is within the work package 4, that's acts as an input to work package 5. So within work package 5, what happens is that the capital cost, installation, operation, and maintenance, that is minimized. So after minimizing that, then we have reliability of the solution is computed, and that's computed from the component failure rates. So when that passes, then we have environmental impact assessment. Now, because we have multiple solutions, if the solution is non-feasible, what happens is that the subsequent run of module 4 is gets into action, which is controlled by work package 5 and work package 6. So for example, if we have a solution that is coming as a pile driven solution, so if that pile driving causes underwater noise, then that will be the environmental impact assessment as a non-feasible solution. So then in the next run, that will not be considered and it will run till a feasible solution is obtained. Now, if we look at the data flow, that is high level data flow with the work package 5, so we can see the inputs that is coming from the user, that is coming from also the other work package and database. Then it goes within the submodules. Actually, 5 submodules are interlinked there. Then after the processing, depending on the technology type, the seabed conditions, we have output in terms of economics, reliability, and environmental impact. Now we have 2 types of systems. One, if we go at the look at the floating system, so we can see the output from the loading, that is system and environmental, that is stopped from going into the foundation module because it is a floating. So it will be mostly mooring lines and that are anchored to the seabed. So from the mooring lines, the loads goes to the foundation submodule to design or to actually identify what type of anchors will be used. So now if we look at the fixed system, what happens is that in the fixed system, we will have a foundation submodule coming into the action, particularly taking the input from the subsystem module, also in subsystem and environmental loads also. So now in this case, the output will be like, it can be pile, it can be Quaison, but the main output that comes out from the work package 5 and overall the DTOcean, it will be economics, reliability, and you can say the environmental impact. Now, if we look at the standards and methods that have been taken care or that have been considered by the DTOcean, they are pretty much same as they are for all the offshore, you can say, devices or structures. Now, the limit states that have been considered by the DTOcean, that are ultimate limit state and accidental limit state only. And maybe in the DTOcean Plus that is coming next year, they have taken also the dynamic part also of it. Regarding the uncertainty of the materials and the loads, that has been taken care by the safety level or the safety factor. So it depends on the risk or the effect that a failure entails. So if the failure produces a very high risk like to life of the operators or something, then we have to keep the safety level high. And regarding the analysis, as Paul was mentioning, it will be static and quasi-static only. So there is no dynamic analysis which actually includes the frequency domain and time domain analysis. And also after the output, there is no structural analysis for foundation elements or components in the DTOcean. Maybe there will be something in the DTOcean Plus. Now, if we look at the DTOcean output, so for the work package 4, it is basically configuration hierarchy and configuration bill of materials. And this goes into as an input to the work package 5 to plan the logistics and work package 6 to plan the reliability. So the overall solution that will be actually refined by the work package 5 and work package 6. And after that, the final assessment we will have in terms of LCOE, reliability, and environmental impact. Now, if we look at the output from this, so we need a detailed and established design and analysis software for further design and analysis of the mooring components. Maybe it can be file, it can be a Quaison, and also mooring lines. Now, for this, there are many commercial these softwares available, and we'll discuss here CSAM because there are some also like Abacus is there also. Now, the CSAM has been there for pretty much time, around 6 years for now. Actually, it was designed for the hydrodynamic and structural analysis of ships and all other offshore structures. In CSAM, what happens is that the simulations are done in a highly relatable environment where analysis during conceptual design involves natural frequency analysis, also their ultimate limit state, serviceability limit state, as well as fatigue limit state. Now, the CSAM has developed over past 60 years with experience, as well as you can see updated every now and then, and it has well-developed packages for a wide range of applications. So there is CSAM for offshore wind, for floating structures, and to our particular interest for work package 5 in our SELKIE project, that is for moorings and foundation. We have CSAM for mooring and risers. Then there is CSAM module for floating offshore wind turbines. Now, for CSAM for mooring and risers has further subtools within it that do different tasks, like deep sea is there, FN corrosion, which takes care of the corrosion of the mooring lines or other components. Silica is there. So there are many subtools within the system for moorings and risers that does analysis for different tasks and gives us an output. So this is very high level introduction to this, and many details can be found in the www.dnvgl.com, so you can go there. So for our work package 5 of SELKIE project, what we have will be building upon these to make them more simple, more reliable, and web-based for us. Thank you. Yeah.
Thank you, Majid, for delving into some of the more technical specifics there. So moving on to Kate Dineen now, who is also working on the tool, and she's going to talk about the assessment of mooring and foundation design practices for ocean energy converters.
Yeah, if Majid could stop sharing his screen and I'll share mine then. Oh yeah, thank you. So. Can you see that?
Yeah.
And you're able to hear me okay?
Yeah.
Great. So I'll start. Yeah, my name is Kate Dineen. I'm currently doing a research master's with UCC and MaREI as part of the SELKIE project. So I'm going to talk today about my project, which is looking at the practices used for mooring and foundation design for wave and tidal energy converters. So here's just a quick overview of my project. So far, I have been using DTOcean to create a model, and I'm looking specifically at the Welsh and Irish geology and wave and tidal environments. I'm looking at the reliability, so the long-term performance of mooring and foundation systems, and uncertainties in loadings as well. Following this, I'm going to put the model through numerical testing to get a more in-depth look at these parameters. So to start off with, I had to look at what design guidance was out there and the procedures within these guides. So as you all know, there's many offshore industries, mainly I would say the guidance is geared towards the oil and gas industries. And there have been attempts to make guidance for mooring and foundation design specifically for wave and tidal energy converters. So the IEC, for example, has a marine energy project. However, I would say lots of this guidance refers heavily on previous oil and gas industry guidance. And of course, while much of what is in that is applicable to wave and tidal energy design, there are limitations where the current guidance doesn't fully capture the nuances of what is required for a mooring and foundation system within the wave and tidal energy industry. So I'll just discuss a few of these limitations now. First off, the safety levels may be too stringent, and this is very topical at the moment, where many believe that the safety factors should be relaxed. And that is because the consequences should mooring failure occur for the oil and gas industry are much more severe than the consequences that occur if a mooring failure happens in the wave and tidal energy industry. So that then as well, the high safety factors drive up the price of the cost of the mooring and foundation systems as well. Secondly, as you all know, moorings for a wave energy converter such as a point absorber may impact the energy extraction efficiency of a device. So while most guidance only considers mooring and foundation systems to operate as a station keeping functionality, they don't really address the need for integrated mooring systems that actually allow the device to extract energy from the waves and tides. Looking at arrays, so while the industry is heading towards deploying densely packed arrays, the current guidance specifies quite large distances between offshore units. And this would just make an array commercially unviable as the footprint would be too large. While again, another difference here would be that while most offshore structures, except for wave and tidal converters, try to operate in areas of low energy so that their platforms remain as steady as possible, the opposite is true for wave and tidal. So while they operate in areas of high wave resonance and high energy, this then means that they're subjected to maybe more cyclical loading, which can induce fatigue in mooring lines. And finally, the size difference between wave and tidal converters and say oil and gas platforms. So wave and tidal converters are generally much smaller, and this then has a knock-on effect about what methodologies can be used when designing mooring and foundations for these. So it is quite clear that the current guidance out there that is mostly dependent on oil and gas guidance doesn't fully capture what the wave and tidal industry requires. And that kind of brings us nicely to mooring and foundation design and analysis tools. So tools can be used to help bridge the gap in the guidance, let's say. So there is quite a broad range of tools out there, from very basic to quite high fidelity. So one could use a fairly basic hazy static tool at the beginning in preliminary design stages and use that to eliminate unsuitable mooring and foundation configurations. Further down the design process, it's possible to model the coupling interaction between the mooring and foundation system and the device using a higher fidelity dynamic analysis tool. And guidance actually recommends using a time domain analysis tool to model the power takeoff system of devices as well. So it just shows that, again, tools are there to aid in mooring and foundation design, and they're very helpful. I personally am using DTOcean at the moment, and I'm finding it very good. So for a preliminary design stage, and I also plan on using Plaxis analysis software in the future to do some further modeling also. So that's kind of where I'm going to finish up. I hope that I gave a bit of an overview on how current procedures outlined in design guidance can possibly be improved and need to be made more relevant to wave and tidal mooring and foundation design. My email address is there, and I also want to reiterate again, even though you're probably sick of hearing it, about the survey and the Mentimeter, and the feedback from that will be very helpful in developing the SELKIE mooring and foundation tool. So I'm going to hand back to Jay now, and thanks very much for the attention.
Thank you very much for that, Kate. So that concludes the presentations about the actual tool itself. We'll now be getting some insight from industry itself. So up next we have Sara Armstrong from DP Energy. You'll be giving a project developer's perspective on this.
Sure. I'm not sure if my screen has started to share yet.
I can't see it just yet, but I'm sure it's loading.
I'll try it again.
Sometimes these things take a moment. There we go. Yeah.
Okay.
You're in
perfect.
presenter mode there for some reason. If you go up to display settings, I think you should be able to go to full screen.
Is it the first one, swap presenter?
I think so, yeah.
Try that one.
Or duplicate slideshow maybe.
Did that work?
Yeah, there we go. There we go. Yeah, we've got the full screen now. Yeah.
Excellent. Thanks very much.
Take it away.
Okay, thank you very much. Hi everyone. Good afternoon, and thanks for having me here today. So yeah, as Jay mentioned, I'm slightly different perspective here. So looking at it from a project developer perspective. So I just want to give a quick introduction to DP Energy for those of you who might not know who we are. So we are a renewable energy project developer, and we have over 25 years experience in developing projects in onshore wind, offshore wind, tidal and solar. And at the moment, we're developing projects in Australia, Canada, and in Ireland. So our main office is located in Butterfint in Cork, but we have other offices in Australia and in Canada as well. So we are a member of the SELKIE project as well. And because we are a tidal energy project developer, I guess we can be considered like a typical end user of the SELKIE tool. So we have two main roles in the SELKIE project. So firstly, we provide feedback and recommendations back to the team on the different features and functions that we would like the SELKIE tool to have. And then secondly, we provide information and data to the SELKIE team from our ongoing projects. And that information might be data like ADCP data, models and third-party consultant reports that we have had commissioned for our sites. And so the SELKIE team are able to use these models and to develop the tools, but also it adds another layer of validation to their models, in addition to the other resources they get from the other stakeholders. So I also want to introduce our tidal energy project, which is Ishkatapa, and it's being developed in the Bay of Fundy in Nova Scotia in Canada. So it's a 9 megawatt project. It's 6 turbines, 1.5 megawatt capacity. And Ishkatapa, it's Irish, so it means fast water. And it's kind of aptly named because the Bay of Fundy tidal flows are quite fast. So this picture here is obviously the Andritz turbine. It's the Mark 1. So it has an 18-meter rotor. It's gravity-based foundations as well. So we plan on using like an optimized version of the Majid turbine, and that the Majid turbine. So that is a project that is 6 megawatts, and it's currently deployed off Scotland's northern coast. Okay, so I know the guys have mentioned earlier that the purpose of this webinar is to inform stakeholders of the main aims and the objectives of SELKIE, but also we want to encourage and generate more feedback on the SELKIE tool functions and features that the marine industry are most interested in having. So from my perspective today, I just wanted to give a few examples and show some ways in which that we plan on using the SELKIE F&M tool from the perspective of a project developer. So here I just have a number of different main areas that we would look at in the initial marine energy project feasibility stages. So when we're looking at examining the viability of a project. So starting on the left, obviously you'll check your resource, whether it's wave energy or tidal energy, and assess your energy yield. Then you move on to looking at your infrastructure. So you want decent access to ports, grid infrastructure, or an alternative route to market. Also, you want to go to supply chain. Then you're looking at your cost of energy and your financial models. Want to make sure your project is viable. Then you might want to start some early stage marine stakeholder engagements. For example, with fisheries, we start that quite early. Then you're moving on to more your scoping and your environmental impact assessment surveys. So with the seabed and the geology, you are looking more at your technical and engineering aspects of the project. And last, but definitely one of the more important aspects is the environment and ecology and checking those impacts. So we would see the SELKIE F&M tool as a way of complementing our own existing in-house expertise, but possibly also filling in some of the gaps. So like, for example, we wouldn't have specialized expertise or the software needed to design moorings or foundations. So we would like to use the SELKIE tool for that. There's 3 main areas in which we'd use the SELKIE F&M tool. So firstly, we'd use it to get high-level information on moorings and foundations to feed into our financial models. Secondly, we'd use it to have informed conversations with stakeholders, for example, fisheries, as I mentioned earlier. And thirdly, we'd use it to get some indicative seabed information or any relevant data that we might need to provide to device developers. For example, if they wanted to check their device design and make sure it was compatible with some of the sites that we were looking at. So I'm just going to look into, give some more detail of these 3 examples. So the first one, looking at, again, cost of energy and financial modeling. So when we're looking at a site, so say we're looking at a tidal site, we tend to take a pretty device agnostic approach, in that we don't have a device developer in mind or a device or a company. So having a tool that will enable us to look at whether it's like a sea-mounted based device versus a floating device, and that would be a really useful tool for us in terms of looking at device footprint, but also overall project area. Another thing we're really interested in is seeing the differences in the design in the moorings or the foundations as you move from site to site. So we would like to be able to see what effect does the meta ocean conditions have, what effect does the water depth have, looking at seabed, what happens when you have different substrates and different geologies, what differences will that make on the designs, and then subsequently, what effect will that have on the costs and the bottom line. So a second example of how we'd use the SELKIE FNM tool would be to have informed engagements with other marine users. As we all know, kind of Ireland has massive potential in our maritime territory. So I have some resource graphs down here at the bottom. So tidal energy on the left, wave energy there in the middle, a kind of massive potential for wave off the west coast, and also offshore wind. That's going to be a key player for Ireland to help us meet our renewable energy targets. So last year we had our climate action plan. More recently then we had the programme for government. So they have outlined plans for 5 gigawatts of offshore wind by 2030. And also they've further plans then to capitalise on 30 gigawatts potential off the Atlantic. So basically wave and tidal energy projects are going to have to coexist with other renewable energy types, but also with other marine users and stakeholders like the leisure industry and also commercial fisheries. So conversations with fisheries is something we do for all our marine projects and generally at a very early stage. So fisheries, they actually have a number of concerns relating to marine renewable energy projects, and their impression of the marine renewable sector is really heavily influenced by their past engagements with the oil and gas industry and basically how that engagement was carried out. So they are a little bit wary. Another concern that they have is in terms of exclusion zones, marine protected areas, areas where they're going to be designated for renewable energy projects, because obviously they're not going to be able to fish in those zones. And if you're making your livelihood from fishing, obviously that's going to be a major concern. Another area they think is a risk as well is the snagging possibilities and gear entanglement. So they had this concern for all types of marine energy devices, so wind, wave and tidal, but it's obviously a greater concern for floating devices and devices with moorings. So these are some of the key questions that fishers tend to ask us when we meet with them kind of early stage. So they want to know, like, what's the overall project area going to be? What's the spacings between the devices? What is the mooring spread? How much does it spread out? In terms of anchors and anchor burials, they want to know how deep is the anchor, how much of the mooring chain is going to be submerged subsea. And again, they just want to know about the structure footprint, but also the overall project area footprint as well. So there are some definite key areas that we'd love to see as an output coming out of the SELKIE FNM tool. And then kind of the third example and the final example of some functionality that we would really welcome within the FNM tool is related to device placements on the seabed and subsequent loadings on the device. So again, this picture here just shows our Ishkatap site. So one of the issues with placing your device is that you want to find the best location within your investigation area. So firstly, you want to optimize your energy yield, obviously. So you want to place your device through perpendicular to the tidal flow. Secondly, you want to account for all obstacles and constraints in the area. So if you have any issues with bathymetry, if there's any existing cables or any existing pipelines, you have to avoid those. And then finally, you want to find an area with a suitably level seabed. So depending on the site, it's actually quite difficult to find an area that that meets all the requirements for every single leg of your device. Obviously, R1 has 3, so sometimes you just have to make do with a bit of slope on your seabed. At the moment, we've taken kind of an iterative approach to how we looked at device loadings and device placement with our device developer. But we think it would be really, really useful feature in the SELKIE FNM tool if they were able to in any way to look at seabed slope and subsequent loading analysis. Okay, yeah, and that's pretty much it for me. I just wanted to give a flavor of how we would use the FNM tool from the perspective of a project developer, because obviously we have very different needs and requirements than a device developer. Thanks very much.
Yeah, thank you very much for that input. Yeah, great to hear some of the things that you take into consideration there that wouldn't necessarily be brought up in say, looking at things on the device scale, like quite interesting to hear about your ongoing discussions with fisheries there. Fishermen. So we'll be moving on to our next speaker now. So we have Matthias Lynch and Pierre Del Belizal. I hope I'm saying your name correctly, by the way, from INOSEE. You're going to be talking about the pre-designed tools they've been using for fixed and floating wind.
Yes, thank you, Jay, for the introduction. And I would like to thank you, the project, for giving us the opportunity to share, let's say, our tools. So we're not, the tools we developed are not for the wave and tidal industry. However, there are some similarities, and they have the same functionalities in the end. So I'm going to share my screen. You should see it now, full screen.
Yeah, looks good.
Okay, so the two tools we're going to discuss are PREDIN. This is a pre-designed tool for bottom fixed foundations, and Stationis, which is a pre-designed tool for floating wind mooring foundations and cabling system. So PREDIN is an in-house tool developed within INOSEE, and Stationis has been developed within a consortium of 5 companies. And yeah, we'll present these two tools then. So just a quick presentation of INOSEE. So INOSEE, we are an engineering services company. We are part of a larger group, which is called LOC, London Offshore Consultants. So in total, we're about 400 and about 100 engineers working, design engineers, let's say, both through the Longitude company, which is our sister company, and INOSEE. So together we are about 100, as I said. INOSEE is more focused on design engineering, so concept development and detailed engineering for in-place conditions, for example. And Longitude is more focused on naval architecture and in-station engineering. So INOSEE, we are 100% involved on marine renewable energy. So our main activities currently are on bottom fixed wind, floating offshore wind, and wave and tidal. And we also currently work quite a lot on floating solar PV. And the other ones are less developed with the company. So on these activities, so we are an engineering services company. We focus on the topics related to structural design, hydrodynamics, and components design, so mooring, foundation, etc. I can just maybe add that on the floating offshore wind, we're part of 2 projects which have been mentioned before, so the Floatant and the Core Wind project. And on one of them, we are particularly in charge of the mooring design on the Core Wind project. So now I'll let Pierre present the foundation design part, and I'll come back for the Stationis floating wind. So Pierre, I don't know if you want to discuss this.
Yeah, sure. I was on mute. Sorry about that. So yeah, hello everybody. So I'm Pierre de Belizal. I'm a structural engineering technical lead at INOSEE. So I will present you briefly the capabilities of INOSEE in terms of foundation design, and then I will have a couple of slides on the software PREDIN that we developed. So we've been working on a foundation design mostly for offshore wind since the start of the company. So we now have few experiences and expertise in that field. So we mostly perform design for wind turbine foundation, but also for offshore substation foundations. So we worked mostly at early stage of the design, so between preliminary and FEED design. And we assessed the structural strengths of various types of foundations, from monopile to jacket, but also gravity-based structures. So we used the commercial softwares mainly, so ANSYS, SACS, or CISAM, but after performing many projects, we realized that there was a need of developing an in-house tool. So I will present this just after. So it's called PREDIN. So we are both using commercial tools and in-house tools. Another thing that is interesting to mention is that for the offshore wind, it's relevant to couple some aeroelastic softwares with foundation design softwares. So we've performed that coupling with bladed and fast, coupling them with SACS and ANSYS. So it's on offshore wind, it's necessary to do such coupling. It may be less relevant for other types of marine energies. So another thing that is to be mentioned, I think, is that now we are part of a larger group, and so we now have the possibility. We have geotechnical experts within the group, so we now have some expertise from soil to the turbine for offshore wind. So the full chain of expertise is part of the group now. I added few references below, so you can see that we worked for various design stages in various areas, mostly in Europe, but also now in Asia as well. And we work for various types of clients. It could be, so the first one, it's a wind turbine supplier, General Electrics, which we work a lot with, but also with developers and with EPCIs as well. Matthias, you can pass to the next one. So, as I said, during the last years, we realized that there was a need of having an in-house tool for the preliminary stages of the design. And the idea is to have very quickly geometry for foundation design. So in the end, we can have the material takeoff and bill of quantities for a type of foundations. So we developed this tool mostly for offshore wind. So it's you can consider a jacket foundation or monopile foundation within the tool, and you can have some natural frequency analysis, ULS and FLS code checks included in the tool as well. And we developed lately a module that enables to retrieve the pile deflections for monopiles in particular. So this tool is developed in Python, and it includes a graphical user interface, so it can make the tool user-friendly. And yeah, I will not talk more about the tool itself because it was dedicated to offshore wind. So, but what I would like to do is to share with you two feedbacks that we think it's interesting to share, because it's so it's feedbacks for offshore wind, but I think it's fully applicable to any types of foundation, so especially tidal or yeah, especially tidal. So the first feedback is that depending on the type of foundations, you don't have the same design drivers, so the design process can be totally different. So to illustrate this, I will make the comparison between monopile and jackets. So for example, for the monopiles, the design driver is mostly inertial loads and the natural frequencies and the dynamic response, especially for large turbines. So it means that at the early stage of the design, it's necessary to perform an integrated load assessment, considering some aeroelastic loads at turbine level, which is not necessary at early stage for jacket design. As the jacket is a more rigid foundations, you can consider that inertial loads has less impact, and you can just focus on loads at wind load at interface between the tower and the foundations. So it's not the same. The design process is different. Another interesting thing to compare is the soil data. For monopile, you need to focus on the lateral soil capacity, which has a huge impact on the stiffness of the whole system. When on the jacket design, you should more focus on the axial soil capacity. So again, it's two different design drivers, so two different types of input data required. And one last thing maybe to mention is that jacket is a more complex geometry, so you need to keep in mind the constructability of the structure you're designing all along the design stages, which is not obviously the case for the monopile, as it's a simpler structure. You can pass to the next slide. So second feedback is that when you're performing design of foundations, you need to find a good balance between the flexibility of your tool and the automatization that that everyone dreams of. I mean by that initially, when we developed our tool, we thought that we would make something fully automatized, and you just need to give few input data and then click on one button, and it will directly optimize your foundations. But we realized that it was first not possible, and then it's not the best way forward. So you still need to have a flexibility, due to the fact that all projects are different, all input data, you don't necessarily have the same input data for all projects. It's not the same design load cases. So for all those reasons, you want to have some flexibility in your tools. So I think in PREDIN, we managed to have this flexibility as we are working with modules that are articulated one with each other. And you can develop new modules if necessary. And there are already also some modules that are already automatized for tasks that are quite repetitive and that does not require so much engineering skills. So this is a compromise we had with PREDIN, and an example of this is that we initially developed PREDIN for offshore wind foundations, but we used PREDIN to perform the detailed design of a tidal turbine that is now on site in North Brittany in Paimpol. So it's a 1 megawatt turbine, and the foundation was designed by PREDIN. So this is how an example of how we adapted our tool to another type of foundation.
Okay,
so that's it for me.
Thank you, Pierre. Yeah. So just one slide to present our capabilities regarding floating wind design. So so we are specialized, let's say, in integrated load assessment using several tools mentioned also by Pierre. So bladed, fast. We do detailed cable engineering, dynamic cable engineering, so configuration assessment and associated analysis. And our third main core activity is the mooring design. So the layout, anchor requirements, and the related analysis using industrial tools, Orcaflex, for example. Some of the pictures are extracted from Orcaflex here. So the tool we developed related to these capabilities is a tool called Stationis. This is developed within a consortium of 4 companies, French companies. There's an internet site if you want to have more details. And it's a pre-designed software for subsea architecture with focus on mooring, cable, inter-array cables, and dynamic cables. So the idea is for pre-design phase, so it can be during tender stage or preliminary design phases where you want to compare the impact of several floater designs, for example. So the aim is to design the electrical architecture, the mooring architecture, and the associated equipment. So in this case, the anchors. Then you can visualize this. So this on the right hand, you see a top view of the layout. So on the right here, you would have the offshore substation, and then you've got the inter-array cables in black, and the moorings here in another color. So then you have a automatic extract of technical reports and drawings. And the main target is to compare different solutions. So you can check for different floaters, for example. You can make your comparisons for different materials within the mooring system. And then you have a set of cost indicators, KPIs, and risk indicators. So you can there's a database within the software. You can add your own ones. And then you can, the aim is to compare all these solutions and try to move along in more details with the ones which seem more relevant from a cost and technical perspective. So here are other figures. So on the bottom right, you see an example for a sub here, and you can see your layout. You can have exclusion zones defined. Yeah, On the top left, you see at some point you can select the floater type. So there's a database of floaters within the software, but you can add your own. So the software, I mean, what it does, there's a frequency domain motion solver that gets, let's say, the motions of the floater, including aerodynamic impact. And then it's coupled to MAP++. It has been mentioned before, so it's a quasi-static mooring solver. And from that, it extracts the tension within the mooring lines. And then there's a specific solver for the dynamic cable configuration. And then based on the loads and the soil conditions, you can assess anchor options. So in the end, you have several stages. Let's say first it generates all your load cases. Then it generates the mooring configurations. You can check several mooring designs, compare mooring designs. Then it generates the wind farm. So with the inter-array cabling and the electrical network associated to it. And then you have the KPIs for your comparison. Yeah, so that's it on my side. It was a quick overview, but if you have any questions, don't hesitate to contact me.
Matthias and Pierre. Yeah, if anybody has any questions, feel free to send them in. We've got one more speaker and then we'll hopefully have some time for discussion. So if you haven't submitted any of your questions yet, please feel free to do so. So moving on from the tools now, we're going to kind of hop back out a bit, and Sophie is going to talk a little bit about the SELKIE network and why you should join it.
Yeah, thanks, Jay. Just getting my screen up there. There we go. Yeah, so hi everyone. Thanks very much for joining us today. And a big thank you to our speakers for some really informative talks there. Just to briefly introduce myself, my name's Sophie. I recently joined the SELKIE project as a project coordinator with Mentamon. So as TJ and Jay mentioned earlier, Mentamon are leading Work Package 3, and we work very closely with Marine Energy Wales to provide engagement with businesses and also knowledge transfer from our academic and industry partners to the wider network we have. So I'm just going to give a quick sort of overview of the SELKIE network today, a bit about how you can get involved and how we may be able to support your business. So the SELKIE network is a free cross-border innovation network where you have the opportunity to join a growing number of businesses in Wales and Ireland that are being connected within the marine renewable energy industry. So not only is it a great way to learn about the sector and gain knowledge and support from leading industry experts, but it's also a fantastic opportunity to gain contacts in the industry and get your business's name out there. So you can, if you join, you can take advantage of the many opportunities and what's now a rapidly growing sector. Really now is the time to join the industry. I think, as you probably know, there's a growing number of marine energy hubs being developed in Wales and Ireland. So it's a really key area for the sector. So there are several ways you can benefit and receive support from us. So these include tailored business support that we can offer through our enterprise hub at Mentamon, but also through our connections with enterprise hubs across Wales and Ireland. We're also offering company-to-company networking. So as everyone can appreciate, I think this year's been a bit of a struggle for sort of gaining valuable networking opportunities. So we're hoping to run a series of virtual networking events in the new year. And these will be tailored to organisations that you would like to be connected with and hopefully gain some valuable contacts that way. We can also provide technical knowledge transfer from the SELKIE tools. So, for example, the Foundations of the Mooring tool discussed earlier. We're also hoping to run workshops on those tools as well. And of course, you'll be kept up to date with any information on events and webinars that we're holding as part of SELKIE. For example, the next webinar we have will be scheduled in January, focusing on skills and skills gaps in the sector. So just on the screen now are just a few examples of companies we have in the network already. So a big thank you to all of those and everyone in our network. As you can see, it's quite a broad range. We have everyone from developers to fabrication to specialist coatings companies, engineering and consultancy companies. And we really do encourage anyone to join, whether you're already working in the sector and have experience, or if you're looking to diversify your work and get involved in marine energy, and we can help and support with that. If you have any questions related to the network and the support that I mentioned today, don't hesitate to contact me at the email address you can see there. I'll be sending out some information on how you can join the network in the coming days, so keep an eye out for that. You can also keep up to date with our mailing list. There's a link on our website, and also our Twitter, our LinkedIn, and the news section on our website will be up to date with all the news and developments of the project there. So once again, thank you for joining us today. I hope you found it useful. And we look forward to hopefully welcoming some of you to the network soon. So thank you.
Thank you very much, Sophie, and thank you to all of our speakers who have joined us today. So we had some questions come in, but Paul has been ploughing through them behind the scenes, answering them. I was wondering, Paul, if you wouldn't mind just discussing some of the answers just for the benefit of our wider audience. There was a few questions directed there about, you know, the tool being quite an undertaking and how you're going to go about it, or I'm just trying to find where some of these other ones. Yeah, how are you looking to validate these tools as well? I wonder if you can just illuminate our audience a bit more with some of those answers you shared.
I can do. Everybody's been watching the talk, so maybe not the chat talk so much. But yeah, we got a question in from Bethan. Thanks for that. So the question was really just how are you looking to validate these tools? And the answer I provided is that we're still kind of defining the scope of our work on the SELKIE project, but we've partnered with one wave energy company, which is Ocean Energy, and one tidal energy company, Sabella, and they're going to help us design not only this decision support tool, but also case studies and validation tests relevant to marine energy in the Ireland-Wales region. One of the thoughts for the design tool is that it will be obviously a preliminary kind of decision support tool. It will produce a basic design, and we might then analyze that further with some advanced simulations and test that. But the short answer really is that the validation studies are kind of yet to be determined. That's part of the reason that we're reaching out today, to understand the needs of the users and just try and ensure that our work provides as much value as we can.
Cool, thank you, Paul. Now, TJ, you shared the Menti link at the beginning. Are we ready to have a look at some of the answers that people have given in? Or can we share the link again so that people are able to participate?
We can have a quick run through it. I'm just conscious that we're gone slightly over time. We actually only have 9 participants, so I'll give one last call if the attendees would like to participate in this survey, and I can share the results.
So this is a short selection of the questions that are going to be in the questionnaire that are feeding into the SELKIE tool. We'll be emailing that round to everybody after the event. And yeah, this is just an opportunity to give some input if you're working in the area, just to kind of feed in to what the key requirements to make this tool as usable as possible are. And yeah, the aim is for it to be open source and to be as valuable to the industry as possible. Yeah, would you like to give us a quick run through of everything we can see here, please, TJ?
Okay. Okay, I just need to, I'm just going to go for the full screen version.
No worries.
And there's still people coming in as well. So we're still getting some responses.
So while we're waiting for people to fill them out, just a reminder that we'll be having our next webinar coming up on the 19th of January. So please save the date. This will be the next in our ongoing series on supply chain opportunities. And this one will be focusing specifically on the skills that are needed for the sector. We'll be covering a range of perspectives from education, from government support, supply chain and developers themselves. And yeah, we'll also be having a recording of this webinar available after the event. And a big thank you as well as to our speakers, to the 54 people who have participated today and came to watch. Wonderful.
Okay, we have 10 responses so far. Back to the beginning. Country, most people from Wales. In which type of business are you involved? We have technology development, consulting, research, and the other. SELKIE project, industry body, Marine Renewable Trade Association, mooring supplier. Quite a diverse range here as well, and I hope everyone gets in touch afterwards. Which industries do you operate? Another broad selection. Okay, do you or have you used open source design tools? If so, which and for what purpose? DTOcean for preliminary sizing and costing? Yes. MaREI OpenFone Octave? No, but heard about OrcaFlex and cupping to ocean models. Python coupled mooring design. There's quite a few around. Which foundation design software do you use? Abacus, OrcaFlex. Which mooring design software do you use? OrcaFlex definitely seems the most common. OrcaFlex mentioned again. Have you used or do you know of the DTOcean decision support tools? Can't get more even response than that. What are the key innovation areas for foundations and moorings? The components, design or materials, the components. And Kate made a very good point as well during her presentation, I thought, when she mentioned about the safety factor and how that influences the cost, and how the safety factor for marine renewable energies devices and arrays could be less than the oil and gas safety factor. It's a really good point. Supply chain and cost anchor types and reducing conservators in design codes. Okay, Jay, that's it.
Cool. Thank you very much for sharing that, TJ. And I think that concludes our webinar. So again, thank you everybody for coming and spending this afternoon with us. Thank you to all of our speakers for sharing their perspectives on what they've been working on, and how their insight can maybe be integrated into the development of this tool. As I mentioned, we'll be having our next webinar on the 19th of January. Please keep an eye on your email mailbox. We'll have a recording of this webinar available and all of the details of our future events. Thank you, everybody, and goodbye.
Thanks, Jay.
Jay.
Thanks, bye.
Thanks, Kate. Bye, Sarah.